which is intended is any material which is intended to come into contact with food. An example of that will be a ceramic coffee cup, for example. It's any material that is already in contact with food, such as food packaging, and Joe's going to be talking a lot about food packaging in his presentation. And it's any material which is reasonably expected to come into contact with food, such as the disposable coffee cup or a napkin. What are FCMs made from? Well, the legislation outlines a non-exhaustive list of about 17 distinct types of food contact materials. And many of these are illustrated in this slide. So it includes things such as plastics, rubber, cork, wood, metal, glass, paper, inks, textiles, and so on. So a large number of different materials will be considered to be food contact materials. But often what we find when we look at food contact materials as they're used in the food industry are often a combination of materials. So if you take a fruit juice carton, for example, a common Tetra Pak, it has a number of different components. And in this slide, you'll see that often it's composed of plastic, aluminium, paper, and ink. So a combination of materials is used often in food contact materials. Where do we find FCMs? Very often, I think there's a misconception about FCMs that they're simply packaging. And while packaging is a very, very key component of the FCM environment, it's not the case that it's just packaging. And what I hope to get across in this slide to everybody on the webinar today is that FCMs are found at practically every stage in the food chain. So what I'm going to do is use an example of milk production to illustrate this point. So if we take milk production from the farm, the milking equipment that's used to take the milk from the cows is an FCM because that needs to be a certain grade. The bulk tanker, which takes the milk from the farm to the dairy, is also a food contact material, as is the equipment for filling the bottles and pasteurizing, and the bottles themselves, including the lids. The truck distributing or bringing the milk to the retailer is also an FCM, as is the retail outlets display units. And finally, the refrigerator that you have at home to store the milk and the glass that you use to drink the milk are all food contact materials. So FCMs, food contact materials, not just packaging, but packaging is an important part, but they are all at every stage of the food chain. And if you use a different food to illustrate this point, you would see that FCMs are part of the entire food chain. So what are they needed for? I think if you consider the slide that I just had up, there's a lot of different things that FCMs are needed for. They're needed for collection of food and harvesting. They're needed for the manufacture or the production of food. They're needed for food safety, for food quality, and for shelf life. They're needed for the distribution of products and the storage of products. They're also needed for marketing and display. They're needed to provide consumer information. An important role of food contact materials, particularly in packaging, is this provision of information to the consumer, which we call FIC. And this is information which the consumer can read on the packaging, such as nutritional declarations, instructions for cooking, ingredient declarations, and so on. So it's very important in that particular role. FCMs are also there for consumer convenience. So there is a push from consumers to be able to have a cup of coffee in a disposable cup, pick up a sandwich in a petrol station. So that's all convenience, and FCMs provide that. And then also they provide or allow for us to consume our food. Knives and forks, glasses, cups, and so on are all there as FCMs and allow us to consume food. So if we come now to some detail around the legislation which concerns FCMs, in Europe, the basic provisions of food contact material legislation have been in place in Europe for over 40 years. In fact, the legislation which relates to FCMs was some of the first food safety legislation which was introduced by the European Union, or the European Community as it was known, in the 1970s. From a legislative perspective, what we have now in the European Union in relation to food contact materials legislation is a mixture of both European Union harmonized laws, which apply to all member states in relation to food contact materials, and I'm going to touch on that in a little more detail in subsequent slides. And we also have some specific national rules in various member state countries in the European Union. And this is because not all of the various types of food contact materials which we encounter have specific harmonized laws as yet at a European Union level. And as such, member states have their own national legislation in place, which covers those specific FCMs which don't have harmonized laws at a European level. So, for example, in Germany, they have their own national legislation which relates to printing inks. In Ireland, we don't have any additional legislation outside of what's in the European Union harmonized laws. We just have the European laws. Just to say, I'm not going to speak about specific national rules in relation to food contact materials today, but if people want to discuss that with me, I'm happy to talk to people after this webinar. There's some very specific rules in certain member states, and I suppose it's important to know that they're there if you're an importer or exporter of food contact materials to other member states. So if we take a look at an overview of EU legislation on food contact materials, what we have in Europe at the moment is a general food contact material regulation, 1935, and a good manufacturing practice regulation, Regulation 2023. These two regulations together apply to all food contact materials, regardless of the type or source. And they are the foundation of the harmonized laws on food contact materials across the whole of the European Union. I'll talk a little more about those regulations in a few moments. For that, I also want to mention the harmonized laws for specific types of food contact materials, or as they're referred to at European level, specific measures. So in the slide here, you'll see sitting under these two framework regulations, a number of specific regulations which relate to specific materials. And if you recall in my previous slide, I mentioned that what we have in the legislation is a list of 17 distinct types of FCMs. So over time, the European Commission has been publishing individual regulations which relate to specific food contact materials. And it's important that you're aware of them, as while 1935 and Regulation 2023 apply to all food contact materials, if you're a producer, say, for example, plastics, you also need to comply with the specific measure that's in place for plastics. And over time, these harmonized laws have developed and have been published at the European level. Now, what I should say at this point is that the European Commission has not published all specific measures for all the food contact materials which are listed in the Framework Regulation 1935. And that's one of the reasons why some member states still have their own national rules in relation to specific food contact materials still in force. Okay, if we move just to look at Regulation 1935, the Framework Regulation in a little more detail, it's often referred to as the Framework Regulation because it outlines the key requirements of food contact material legislation. It outlines the general requirements for preventing food contamination from food contact materials. It outlines some labeling provisions in relation to FCMs, and it also outlines some traceability requirements in relation to FCMs, in addition to a whole lot of other things which I'm not going to talk about today. It also allows the legislative process for the European Commission to publish those specific measures I mentioned on individual food contact materials, such as plastics and ceramics and so on. And it also allows for the authorization process of substances which are used in food contact materials. So if you're a manufacturer, say, for example, of a plastic product and you want to use a certain substance, that substance has to go through a risk assessment evaluation by the European Food Safety Authority before that substance can be put on an authorized list of substances to be used in the manufacture of plastics. Now, I'll come back to this a little later in next few slides. Just to say, the Framework Regulation 1935, it covers all the parts of the food contact material environment, from the primary manufacturers of the raw materials used to produce FCMs right up to where the industry is using these FCMs to package food, or the retailers are selling cling film, tin foil, and so on to consumers. It doesn't include the final consumers, because the final consumer is just the end user of the product. So the regulations relate to everything before that, and everything inside that box that's on the screen at the moment is within the scope of the Framework Regulation 1935. Within the regulation, there are some underlying principles. The key principle of the regulation is, of course, safety. And Article 3 of the regulation outlines that principle in saying that any material or article intended to come into contact with food, directly or indirectly, must be manufactured. So that substance so that substances are not transferred to food in quantities large enough to endanger human health, and that's the key one, it's the food safety piece, but also to bring about unacceptable change in the composition of the food or cause a deterioration in its organoleptic properties, in other words, a taint. So in relation to that, and I'm going to kind of just talk about the safety aspect. An important thing to talk about when you're talking about safety of FCMs is establishing the migration of chemicals from the material that's in the FCM to the food product. And on this slide here, I'm showing an example of how that works. Migration tests are laboratory-based tests where we measure the transfer of chemicals from the food contact material into the food. And as an example of that, I have this soft drink in a plastic container on the slide. Like all food contact materials, plastics are made from a specific set of chemical ingredients or substances. And as I said previously, those substances have to be authorized for use by the European Food Safety Authority. The transfer of these chemicals from the plastic into the food is influenced by a number of factors, and they're outlined on the right-hand side of the slide. And by determining the impact of these factors on the migration level, the lab can determine and predict the safety of a food contact material when it's used with various types of food. So when the laboratory is asked to perform a migration test to determine the safety of a food contact material, they take into consideration the type of material that we're talking about, in this case plastic. They look at the type of food that plastic is going to hold. Is it a dry food, a fatty food, a wet food? What are the conditions that food presents? Are they acid or alkaline? How will that product be stored in terms of temperature and pressure? And how long is the shelf life of that food, or how long will the food be in contact with the food contact material? And using some very complex mathematical calculations and some software, usually, the lab can actually come up with a prediction for migration of the material of interest or the substance of interest from the plastic into the food, and then can determine if that particular material will comply with the legislation. And this slide is really just for illustration purposes, just to show that this is the kind of thing the laboratory will actually produce. Another underlying principle of Regulation 1935 is traceability. And I'm sure everyone on the call will be familiar with the concept of traceability. In relation to foods in general, Article 18 of Regulation 178 outlines traceability requirements for food. And here, manufacturers of food are required to have one step back, one step forward traceability. The same applies to food contact materials, and this is outlined under Article 17 of that regulation. Finally, one other thing I just want to mention on Regulation 1935 today, which I think is important, is labelling. Under Article 15 of the regulation, it states that materials and articles not already in contact with foodstuffs must be accompanied by the words "for food contact." So that's to show that that material is to be used for food contact. Or you can put a specific indication as to the use of the food contact material. For example, if it's a spoon, it's a soup spoon. Sometimes it's obvious, sometimes it's not so obvious. Or what you might have noticed maybe on some food contact materials, such as Tupperware or plastic pots, is this symbol here. And this indicates that the material is suitable for contact with food. Or, and if necessary, you can include special instructions with the material for use, or the trade name or registered office of the supplier, and some other information as you deem necessary. Finally, just to mention the Good Manufacturing Regulation 2023. This is the last piece of legislation I want to briefly outline today. And again, with the Framework Regulation 1935, it forms the foundation of the harmonised legislation which is in the European Union. As the title of this regulation suggests, this regulation is all about how food contact materials are manufactured. And this is very important when you want to minimise risk to consumers. So in this regulation, it lays down the general rules on how food contact materials should be manufactured. It applies to all 17 food contact materials which are listed in Regulation 1935, combinations of these food contact materials or recycled materials which are made or used in them. And again, like the framework regulation in 1935, it applies to all stages, sectors of manufacture, processing, and distribution of these materials. Before I finish up, I thought it might be useful to give you some indication of where we're going with the EU rules or the EU legislation on food contact materials. As I said to you at the very start, the basic provisions of food contact material legislation have been in place in Europe for over 40 years. But in that time, there hasn't been any real systematic assessment or evaluation of the legislation. So I suppose the European Commission put the legislation in place, member states adopted it into their own national legislation, but we've never really evaluated how the legislation was working. Was it actually adequate? Was it doing the job of protecting the consumer, and so on? So back in 2020, the European Union decided that as part of the Farm to Fork strategy, they would actually start looking at the legislation to evaluate if the legislation is actually doing what it should do 40 years on, or if it needs to be amended or changed. And as part of that process, the European Commission has committed to revise the legislation to improve food safety and public health. In particular, what they're looking at is reducing the use of hazardous chemicals. So they want the industry to look carefully at what they're using in packaging, in equipment, and so on, and try and limit the amount of hazardous chemicals that they use. Now, sometimes it's not possible to do that, but again, it's to kind of put that thought in the manufacturers and the users of FCMs that they should try and limit the use of hazardous chemicals. They also want to support the use of innovative and sustainable packaging solutions with environmentally friendly, reusable, recycled materials. So as an example of that, the European Commission last year, back in October, they brought out a new recycling regulation in relation to PET plastics. And over time, that regulation will be amended to include other materials which will be used for recycling. And finally, as a key pillar of this kind of process of legislation revision and risk assessment, they want to contribute to food waste reduction. So they want FCMs to be part of this whole process of reducing the amount of waste, food that we waste as a society going forward. So it's part of the process to look at the legislation and see where the legislation can be strengthened to, encourage food waste reduction, both by consumers and by manufacturers. So there's some of the key things that work is looking at. On the European Commission website, and I have links in this presentation to it, you can see further details of that work. What we're expecting to see is a new framework regulation, probably in 2025. That's my current timeline on that, but it may be before that or maybe slightly after that, but roughly around 2025. Okay, so just to conclude, and in summary, I suppose from looking at the legislation and how it's framed and how it's worded, I think producing and using safe food contact materials is everybody's responsibility in the food chain. We need cooperation at all steps in the supply chain to ensure food safety and compliance with the regulations. And for the purpose of today's presentation, I think the key regulations to think about are Regulation 1935 and Regulation 2223, and to be aware of the specific measures which sit underneath those particular framework regulations. There are quite a bit of resources and support available both on the European Commission website and our own website, and indeed the European Food Safety Authority. And what I did say to Safe Food is that I have drawn up a short 3-page document which I can make available to people on the call today, which outlines both the legislative framework and who does what in the the food contact materials sphere. So with that, I'll thank you for your attention, and I'll hand back to James. Thank you, James.
Thanks, Carl, and thanks for the onerous task of condensing what's clearly a huge body of legislation into 20 minutes. So well done on that. We've had just a number of questions, which I'll take now. What is your opinion on using reusable, returnable glass bottles? That seems to be topical again.
Glass, like in terms of the FCM legislation, James, I mean, glass is, it's regularly recycled. We don't have a specific piece of legislation on recycling glass, but it's a relatively safe, inert FCM, and has been used for quite a long time in the food industry. with little or no issues associated with it. So I would see that continuing. What I would say is that there has been talk at commission level in relation to a specific measure for glass and ceramics, not ceramics, glass and enamels and a few other materials. So we may see a specific piece of legislation on glass going forward across the European Union, but that won't hamper recycling of glass. That's going to continue, and it will be in keeping, as well, I suppose, James, with the Commission's farm to fork strategy.
Yeah. Another question, can you expand on the equation that you showed for the migration model? Somebody wants to know, what exactly does C and H values represent in that?
I've no idea. I'm not a chemist. I just put it up there so you can see. I mean, from my perspective, we have one laboratory here in the Republic of Ireland which deals with food contact materials. So when they're doing migration tests, those symbols in that mathematical formula, they represent the variables that I had on the screen. So they could be pressure, time, and so on. And that's what they put in.
Concentration.
So when they get
the
data, exactly. Yes, exactly.
Yeah. And then it's the final question, does more need to be done on the novel foods processes legislation to help in the adoption of better or safer FCMs? So,
novel foods. I can't really speak to the novel food regulation, James, if I'm honest. Right. I know someone who could, but he's not on the call today, so I'm not sure I could. I'm not sure I'm understanding the question either. I mean, we do on the recycling end of things in the new recycling regulation. There is a section which deals with novel recycling technologies. I don't know if that's what the question is aimed at, but if it's novel foods, that's not quite my area of expertise, so I can't really answer that question.
Yeah. A few more questions have come in, actually. What is the perspective, or your perspective, on removing plastics for products such as breads, where the cardboard is made from a 100% recyclable material? Well,
I suppose just to say, the FSAI, we just enforce the legislation. So that discussion is not for me to have. Yes. I suppose what I would say is we'd be in a better place to make comments on that when the Commission has put in place harmonised legislation for cardboard and paper at a European level, and we see what that legislation looks like. When every piece of legislation comes into place, James, we would sample and take samples, test them to make sure they're complying with the legislation. I suppose when that happens, and if we identify a problem, then I might be in a better position to give an opinion on that. But at the moment, I couldn't really say. And as I say, we just enforce the legislation. We don't make kind of comments on policy like that.
And I presume you mentioned already with regard to glass, the reuse of glass, that there'd probably be some new legislation coming through from the Commission at some stage that would then lead on to maybe incentives for companies to use glass. Because one of the other questions here is with regard to reusing packaging such as glass. Will companies be given incentives on using glass, financial incentives, for instance, as part of that?
I think it's important. I think it's important to say, James, that we fully support recycling of food contact materials. That's not something we shy away from. I suppose what you have to be careful about is, if you recycle a food contact material, are you introducing an additional risk by doing that? So from our perspective, we just look at the safety of the food that packaging or that material is going to be used in. If it's been used in manufacture, we look at, is that going to impact on the safety? So if I talk about the one I know, the one we currently have, which is the recycling regulation, that whole regulation is designed around decontaminating plastic, so that plastic can be used safely in recycled packaging and recycled materials for contact with food. So we fully support recycling, and as I say, in time there's going to be new pieces of legislation which cover glass and metal and other materials. But at the moment, we would fully support recycling and sustainable recycling. But the only regulation we have at the moment, as regards food contact materials and recycling, is the one related to plastics, and PET is the type of plastic.
Yeah, no, that's fine. Okay, folks, thanks for those questions. I'm conscious of the time, and I'm going to move on to thanks, Carl, for that presentation and for answering the Q&A. So I'd like to move on to our keynote presenter today, which is Joe Carey. So Joe, without further ado, I'll hand over to you.
Hello, everybody, thanks, James and Safe Food, for inviting me to give this presentation actually today. I'm just going to share my screen with you now. Hopefully that's it there. Yeah. I hope everybody can actually see that.
Yep, and, all good. Thanks, Joe.
Yeah, great. And I'm just going to let me see if I can, everything's kind of moved around the place actually here. I'm going to try and just I can't actually get rid of my screen, I think. Let me see. Anyway, that's, yeah, I think we're okay now. So actually, just a little bit thanks to Safe Food and James. Sorry, I got a bit distracted there with all the moving around. My name is Joe Carey. I'm head of the Food Packaging and Material Sciences Group in UCC. For those of you who don't know me or don't know the group, we were set up as an industry initiative actually in UCC back in the academic year of 1999-2000. So we're nearly 23 years actually in existence, and the remit, in addition to making sure that we were actually training graduates and that we sent graduates actually out to industry with an education and a fundamental understanding of packaging. We also were charged with trying to actually start doing research and interacting with industry. And over the 23 years, essentially in terms of the research activities that we've actually had, we've always tried to make sure that 50% of what we did and what we were looking at from a packaging point of view was very much geared and interacting and working with the food industry in relation to all different aspects of food packaging. And the group in existence today is made up of 12 members, but we've kind of ranged from that up to about 26 over that period of time. So I like to think that we're kind of an industrially focused group, and I trust that of all of the participants today, there's quite a few from the food and beverage sector present. So anyway, I couldn't really go on actually with a presentation without reminding everybody what packaging actually is supposed to do. And I suppose the idea of this particular talk is really just to sort of give, I suppose, my own views in relation to packaging over the past 23 years, where it's actually kind of come from and the challenges that it actually faces, particularly over the coming decades. But irrespective of all challenges, new challenges, there's always been a set of rules that govern the correct application of packaging to products. And that doesn't mean that at the end of this perfect process, we don't end up having packaging problems. But essentially, the problems that you have should be minor rather than major. And when we actually go through the fundamentals of packaging, of course, selecting packaging is an economic process, but it contains within it aspects of science and non-science approaches to making sure that essentially you get the packaging right around the product that you're trying to pack. And so three technical terms, or what we call the technical functions of packaging, is to contain and protect and preserve a product. So when we talk about preservation, we're really talking about shelf life. When we're talking about protecting a product, it means that we're trying to apply packaging to prevent the product from being physically damaged. And containment, which actually comes at the start of all of the fundamental terms, is a really, really important one, because it has actually very little to do with packaging itself. It has everything to do with you asking questions about the product that you're trying to pack. And it asks questions of how well you actually know your product, because essentially the rule of thumb from a packaging point of view is you can't pack what you don't know. And essentially, I would say if I was to go through all of the different scenarios that we've interacted with industry over the past 20 odd years, I would say that 90% of the time, the issue is never actually to do with packaging, but more actually to do with containment, which means the manufacturer's own understanding of the product that they're actually manufacturing and trying to pack. Then on top of that, we actually have, of course, the role of information being required to be applied by packaging. And of course, information is divided into two areas, that which has to legally be on the pack, and that which in actual fact is at the option or discretion of the manufacturer. Then we have convenience, and convenience is a lot more than worrying about whether or not you can open and close a pack. But it's actually about as you move your product from the manufacturer all the way through to the consumer, essentially how convenient has it been for everybody who's actually had to encounter the product packed in a different way throughout the distribution chain. And of course, finally, whatever packaging materials we use, and as Carol has alluded to, has to actually be legally compliant and sound, and of course has to be considered also in terms of its environmental impact. And this last one is, I suppose, environment is everything for the last 10 or 12 years. And it's where a lot of challenges to packaging systems and materials are actually going to come from in the decades ahead. So that's just a definition. Again, and if anybody was actually involved in trying to apply a packaging system or materials to a product, I would say start with this definition, make sure you have the keywords at hand, and while you will still make mistakes, you won't make major ones. So when we actually know and understand all of that, we have to also be aware that that fundamental knowledge in applying the fundamentals to packaging has to work at 3 levels of packaging. So packaging actually as an industry is divided into 3 different sectors. The first one is the primary packaging. We call that usually the sales packaging, and that's actually what we usually see when we walk actually into a supermarket. Of course, primary packs actually aren't sent through the distribution chain like that, but they will often be packed in secondary packaging. And the secondary packaging is where we place our primary packs, a number of units, into a kind of a corrugated paperboard box. And essentially it's for collation and handling purpose. So we're gathering units, that's collation, and thereby at the end of it actually having a pack that people will be able to physically handle under health and safety guidelines. And of course, again, secondary packs, unless you're a really small producer, essentially will go to another level, which is where in actual fact you are now going to place a number of these secondary packs on a pallet, and that would actually be called transport packaging, and that is for, again, distribution and transport of the product from the point of manufacture through to various different storage depots all the way through to your retailer. So the fundamental rules that we actually just went through in the previous slide has to work at all 3 of these levels. And we're talking about using completely different packaging formats and different packaging materials actually here. Now, one of the things that I've actually noticed, and in particular over the last 2 decades, is that while a lot of our packaging formats and materials actually haven't changed at all, they are expected actually to do a lot more than a lot of them were actually ever designed to do. And like one really good example of this is, for example, how over the last 20 years, our products now, like food and beverage products, are actually moved to much farther flung parts of the world, where now we have markets in BRIC countries. So that would be India, China, and South America, when we actually didn't have those really about 20 odd years ago or more. And essentially the products that actually were packed for the UK market and for the European market, they're practically the same materials and formats that are actually still being used, but we're actually moving them over much greater distances. So the packaging materials and systems are doing a lot more than they were actually ever designed to do. And I think it's something actually to be mindful of, particularly when we may have challenges actually coming down the line that actually start to undermine the structures, these type of structures that we have probably spent 150 odd years trying to develop. So we have to be very careful about the changes that we implement around the packaging materials. And I know, talking to a lot of companies over the years, they were exasperated by the fact that, oh my God, packaging is terrible. It just seems to be this convoluted thing that has lots and lots of different layers of factors. And when issues basically pop up, we never actually know how to actually address these issues because they seem to be coming from all over the place. So about 10 years ago, I actually sat down and I started looking at scientific literature and non-scientific literature and started looking at all the various different types of issues that popped up with packaging like over the years. And I would say that on the basis of that listing, which is presented here to you on this particular slide, they form actually the present challenges that we have and future challenges. And in the last 10 years, I've had no real reason to add another factor to this. So it's not endless, but it is complicated. And I won't go through each one of these now, but two that I'm actually going to focus on, and we'll see this as we actually go towards the end of the talk, are the two actually where two really important functions of packaging is that packaging, in terms of the formats and materials that we continue to use to this day, they have actually evolved to try and deal with one specific issue, and that is food waste, and trying to actually maintain products for a much longer period of time, which is really about shelf life. And one of the big challenges really in terms of the formats and the materials that we use for packaging now is actually coming from the environmental concerns and issues that are pertaining to packaging sustainability. And we have very, very fast movement around the areas of actually trying to implement packaging sustainability. And I've seen, and I know a lot of companies that basically have done this, where essentially we'll see later on, for example, that laminated structures are sort of being sort of discarded, or I suppose in a way you're encouraged not to use them because of the difficulties in recycling. And then people actually move to packaging systems that are more recyclable, which is all fair enough. But one of the things that I know of companies that have actually done this on the back of pressure being applied to move to more recycling friendly formatted packaging is that very few of the same companies have actually carried out any shelf life assessment on their products. So in other words, if I've actually moved from a complicated packaging system to a more simplified one on recycling grounds, like one of the questions I would have for anyone who actually did that is, well, did you actually carry out any shelf life studies to determine whether or not there was a knock-on effect from the point of view of reducing shelf life? Because if that happens, then we could be talking about food waste, which then actually, in a way, we're undermining the very systems that we try to put in place to try and minimize food waste. So again, one of the, I suppose, before I actually go on talking about like some of the technologies that are at hand and we might be able to use in terms of trying to help the packaging that we use around products now, we developed some terminology in our own packaging group, and we call it first level versus second level packaging. So essentially, we try to keep these kind of terms very simple. First level packaging is really the packaging that has actually evolved over the last 150 odd years, both in terms of format and in terms of materials. And essentially, it's what we see typically when we walk into the supermarket and we see the products actually on the supermarket shelf. A lot of the materials that Carl alluded to earlier on in terms of paper and plastic and glass, they all form first level packaging. And like I said, this packaging is working overtime in that it's doing a lot more than it was actually ever designed to do. But one of the things is that if there are more challenges actually to the packaging formats and systems that we actually have, we have to be very mindful that if we are asking the materials to do more and yet actually starting to come from different perspectives where we're simplifying the actual packaging formats too much, we may actually be running the risk of reducing safety, reducing quality of products, and reducing shelf life. Now, all is not lost insofar as first level packaging is concerned. There has always been help, and particularly over the last 20 years, in the form of what we call second level packaging. And second level packaging is actually, it's not more material, it's not huge amounts of material, but rather more discrete technologies that can be implanted within, outside, or around the actual packaging, the first level packaging, so that in actual fact, these devices can actually help the primary packaging cope with these additional challenges. And so again, I'm not going to, I've kind of already kind of highlighted like what first level packaging are, but here's lots of different examples, everything from vacuum packs to modified atmospheric gas flushing, to canning, to jarring, and so on. So these actually all constitute our first level packaging formats. And even with that, and even when we're trying to do everything now, where we're not really undermining very much of the packaging systems that we have in place, we still have packaging problems with food products. And even in some of the images that you actually see here, you can see examples of where, for example, where we think we actually have the right packaging formats, where we've used the best of materials, and yet we're still actually having issues with the migration maybe of oxygen into a pack, causing oxidation, or through the promotion of microbial growth, or maybe overexposure of UV light, for example, on cured meats, which causes color fading. There's a lot of different types of factors that still impact those kind of packaging systems that we have come to know and have developed over 150 odd years. So you can imagine that if we have these issues now with current systems, we have to be very, very careful and mindful of undermining these with systems that may not actually be as good as even the ones you're looking at here on the screen that have failed to do their job properly. So enter second level packaging, and second level packaging in actual fact falls under a number of different technologies. And not to bore you with all of these, essentially you can take second level packaging. Another name for this from a scientific point of view is smart packaging. And smart packaging can actually be divided into three different sectors. One is what we call active packaging. The second one is intelligent packaging. And the last one is consumer interfacing. Now, active packaging, in my mind, and in terms of the context of the talk that I'm actually giving here today, active packaging is really important insofar as if we use some of these smaller technologies and build them actually inside and around our packs, what these technologies will do is interact in the internal part of the actual pack. So where our product is packed, it's in there that these technologies will actually work. And essentially they can do all sorts of various different things. They can remove substances that we don't want in the pack over time. They can add certain things into the pack to try and enhance shelf life of the actual product. And just to show you an example here, a very old technology. A lot of you will have seen these kind of sachets, for example, that will be present inside in this case in beef jerky or these type of products. These are oxygen scavengers, and the purpose of the oxygen scavenger, of course, is to remove any residual oxygen that may remain inside in that pack and prevent oxidation and discoloration from happening to the actual product. In this case, that's the reason for using the oxygen scavenger. And again, these technologies are useful insofar as if you apply them, you can influence the shelf life of the product. So they interact with the product, they interact with the internal environment of the pack, and enhance, hopefully, the shelf life of the actual product. Intelligent packaging, on the other hand, while it interacts with the product, doesn't do anything from a shelf life point of view or change the condition of the food in any way. What this simply does is it gives us an indication, it gives us a history about what has happened with the actual product, maybe throughout the distribution process. So this kind of an example that I have here is an example of a time temperature indicator. And essentially what happens is that at the point of manufacture, your sensor should actually, your indicator should look like this. And if, for example, the product has been temperature abused, by the time it actually gets to retail, then you'll actually have this color, which actually just simply shows you that throughout the distribution history of this product actually has been temperature abused, and then you can actually form your own or come up with your own actions around what you're actually going to do with that pallet of product, for example, that is actually showing signs of temperature abuse. Do you actually sell the product, or do you actually pass it back to some other part actually in the distribution chain, which would actually have to take responsibility for maybe this temperature abuse? So again, that's another form of technology that falls into the second level packaging. And the third one, which is kind of the new kid on the block really, is kind of consumer interfacing technologies, is the term that we actually use for them. And this is simply like technology that's built actually onto the side of packs, and essentially is of no value unless the consumer actually interacts with it. And so you'll often end up like seeing, for example, in a supermarket, somebody with a phone, with their smartphone, actually scanning a particular code. That would probably be a rapid communication code. And the idea is they're trying to get more information actually about the product. The example that actually is here is a 3D printed electronic code that actually is the cooking instructions that's fed into a smart oven on all of the stages that you would actually go through to cook the ready meal in question actually here. So we have different types of technologies that exist in second level packaging, but I'm going to kind of focus more on the active packaging. And so just to describe this in a little bit more detail, our active packaging, which you now know actually interacts with a product to try and extend the shelf life of its product, can work in different ways. As we saw in the last slide, you can actually have those technologies which are absorbing or scavenging. The idea there is that they're taking something that's unwanted from the inside of the pack, and by removing it, improving the condition of the food product or beverage product in that particular pack. Big ones like is the removal of oxygen, the removal of moisture, the removal of ethylene, which is a plant hormone that causes the ripening of products. We can even have coatings, for example, that cuts down or reduces UV penetration of the actual product as well. If we are not going the route of absorbing something from the pack, then we can use technologies that go the opposite direction and release something actually into the pack. So for example, releasing or emitting technologies would be where, for example, ethanol, very, very low concentrations of ethanol as a vapor be allowed, for example, for use in bread, because we know that yeast and molds don't like an ethanol vapor actually around them. Equally, carbon dioxide is a selective bacteriostatic gas. And so for really fast food spoilers like Pseudomonas, for example, the use of carbon dioxide essentially prevents or discourages their growth inside in a food pack. You can have releasing or emitting technologies that release antioxidants if you have oxidation type problems, or even preservatives or antimicrobials. And we have other technologies besides these that control temperature, that are activated with light sources to work in various different ways. So there's lots more technologies other than what I've actually shown here. But just to kind of dwell on two, because it happens to be topical, most of the work that actually is going on in this space is around the use of packaging materials that, for example, could be coated with antimicrobial agents or substances. And essentially, these substances could be mobile, which would mean that the packaging materials could allow the release of these materials into a product, provided, of course, they're food grade and safe. Or if you're worried about that, you can actually have what we call immobilized systems, which means that you can actually coat the packaging materials with these substances. And the idea is that they don't migrate. They literally, the effect is as a result of the packaging meeting the bacteria on the surface of the food and essentially preventing the microorganisms from growing. And what you actually see here is a picture in our own lab of a packaging material that's been coated with an antimicrobial. This one is mobile, and you can actually see, for example, that the coating on the packaging, not alone has it actually killed off the bacteria under it, but actually even around it. And this is just the same approach that's actually used to screening for antibiotics, for example. So again, that's one approach, and people understand that trying to prevent the growth of microorganisms as primary food spoilers would be a real way of extending the shelf life of packaging. And you're literally talking just about putting a coating on existing or first level packaging. Another one that's actually very topical and really has been an issue for the last 5 or 6 years, and this has actually been around the use of CO2. So anybody involved in the manufacture of beverages or gas flushing food products from an MAP, modified atmosphere packaging point of view, will be aware that there has been supply issues around the use of CO2, and now those issues seem to be getting worse. There's now issues around people guaranteeing the concentration and purity and cleanliness of the gases that are actually being used as well. Now, I know companies that are basically looking at this particular technology, which has been around for 20 to 30 years. And essentially, these are active packaging systems that are emitting. So the idea would be that instead of worrying about the purity of gas and the availability of CO2, why couldn't you actually just have a technology that you placed inside in a pack and that emitted CO2 in various different ways? And so you knew that the CO2 generated was actually generated naturally within the actual pack and gave you the preservative effects that you actually wanted. This technology I've always loved. And this one is actually where, for example, we have this pad. Most of you will have seen these pads actually underneath a product that has a lot of moisture, like meat, for example, or poultry or fish. And of course, its job, and again, it's an active packaging system. Its main job is to mop up water and drip loss from the actual products, thereby extending the shelf life of the actual product. But on the inside of these pads, you also actually have technologies that are built in there, which in actual fact are seeded. So we have chemical compounds inside in that pad that in actual fact, once the moisture makes its way into the pad, a number of things happen. We can have an oxygen scavenger that starts to work, which tries to remove residual oxygen that's inside in the pack, right? And at the same time, we have other chemicals that in actual fact will react with the same moisture and release CO2 into the pack. So we have oxygen scavenging, we have CO2 release, and we're also mopping up the moisture inside in the packs. This is a real alternative to people who are actually struggling with trying to source and use gas from gas bottles in gas flushing operations in food products. Now, one of the things that in actual fact, and this is where I kind of move to another side, and where I think a massive challenge is actually coming to a lot of our conventional food packaging systems. And this is really from an environmental point of view. A lot of you will actually be aware of the single-use plastic object ban, which the EU implemented a number of years ago. And as that rolls out, more and more of these single-use plastic objects start to disappear from the markets. In addition to that, though, there are actually plastics that are already that have been used for years and years around food products that are on the endangered species list, I would describe it as. And essentially, while they have been workhorses in their own right in the 1970s and 1980s and beyond, issues have started to arise now around the use of some of these plastics for food use, mainly because of recycling issues and trying to deal with the recycling of certain types of plastics. So PVC, or polyvinyl chloride, or PVDC, which is called polyvinyl leadine chloride, essentially have been fantastic plastics, but unfortunately recycling them is very, very difficult, very, very costly, and essentially you end up with a lot of byproducts that are not environmentally friendly. So while on a list of plastics for use in food, you will still see them there, a lot of companies have already moved away and moved to new packaging structures where these plastics are actually no longer used. And essentially, where they're no longer used is definitely in laminates. And as most people will know, a laminate is where you stick a number of different materials actually together. And PVDC in particular would have been used as a fantastic gas barrier in laminated structures. And so it is now gone, as are a lot of laminates that have been used for challenging food products and have been replaced by single layer plastics, or supposedly single layer plastics, on the basis that they're recyclable. So I suppose one of the things that we actually have to be careful of is that if a lot of this actually happens in a way where it's not monitored properly, and we start to lose plastics that had very important functions from a packaging point of view, we may run ourselves into trouble around issues to do with food waste. And unfortunately, if that's not being measured now, as these implementations are actually required around packaging, we may actually find out that we have a food waste problem that's actually bigger than it is today, but we'll only find out about it in maybe 5 or 10 years' time. So, I mean, one of the talks about it is, well, if these plastics actually start to disappear, where are the future packaging materials basically going to come from? And so everybody is actually talking about sustainable forms of packaging, compostable forms of packaging, edible and biodegradable packaging, or non-edible biodegradable packaging. And essentially, it's not to wreck your head, but just to kind of show you the palette of materials that are actually being presented to us scientists to basically look at them in terms of potential materials that come from natural sources that might actually replace packaging. The problem actually with this is that this is not going to be done today or tomorrow. If it took us 150 odd years to actually develop the systems that we have in place today, you can imagine, even though there's a lot of work being done on a lot of these materials, we have a long way to go before a lot of these materials ever make their way in to compete with packaging materials. And the one that basically has really been the one to come to market has actually been this one, which is our polylactic acid, or PLA. And all of these are actually bio-based polymers. So the idea is that we'll eventually be able to make polymers from all of these natural sources, but it's going to take time and a lot of research in order to do so. So PLA, in actual fact, has been used for single plastics for beverages, and you'll often end up like seeing the same materials, for example, used around bags of fruit and veg and so on. The problem is that, like, we've done probably about 40 years worth of work actually on this, and there are still limitations in the use of this particular compostable plastic. So there's still lots of work actually to be done on this one, but it is the one that actually has come through into industry. So I suppose I'm just coming to the end now of the talk, and this is really my last slide actually. But what I actually just wanted to kind of show is where some of the challenges are actually coming from, the threat that we should be very much aware of from the conventional packaging point of view, and about potential and alternatives that are actually there to try and help our conventional packaging systems, as maybe they actually are forced to change from a legal point of view. But I would certainly say to most companies who are kind of caught between all of this is to be very careful in reducing anything without carrying out proper shelf life evaluations of your products to all of the various markets that your products actually would go to not basically make any major changes to the packaging unless you're also trying to evaluate the shelf life of those same products. So on that note, I just say thanks a million for your attention. And if you have any questions, I'd be very happy to answer them.
Thanks, Joe. We have a number of questions kind of come through. One person wants to know if you can share the list of testing and packaging that any food company would need to complete prior to putting a food product on the market. Or is there some location or portal, for instance, that a food company could actually get this information?
Say that again, James. Maybe I missed the
I think if a food company wants to put a product on the market,
yeah,
and they want to find out, well, where's the list of testing of packaging that they would need to do or complete in order to put that product on the market? Like, where do they go for that information? Who has that information? Is it the FSAI, or is it some separate company, or what?
Well, usually somebody. Well, a good source is always the FSAI, particularly in terms of like, and as Carol alluded to, you know, on what packaging materials are there, even all the way down to the recycled materials. But most people thinking about putting a product out to some market, wherever it actually happens to be, would probably have a fair good idea looking at competitors as to the type of formats and packaging materials that they're probably using. And then actually after that is once you actually start engaging with a packaging company that's coming very, very close to a material you think is going to work for your product, essentially they should, when they're talking to you about the packaging materials, should be giving you specification sheets or documents for the packaging materials. And that's really, really important. I know of food companies that have worked with packaging suppliers for 20 years and never asked them for a specification document in their life. So the bottom line on a specification document is a specification document, first of all, tells you what material is there, whether it's a single plastic or a complex laminate. It will then go on and tell you about all the physical strengths and all the physical features, the gas barrier properties that's required for the actual product, its ability to heat seal, its ability to print and color, and so on. All of these usually appear on a specification document associated with a packaging material that you're thinking of buying. And most packaging materials or most packaging suppliers have them, and quite a lot actually when they're I suppose consigning an order over to a manufacturer, give that information as well, so that the manufacturer has reference to the tests.
Will the specification document tell you what kind of materials or what kind of foods you can use it with as well? It
won't end up like, well, I suppose, see, therein actually, if you're
like maybe acidic foods, or, you know, not acidic.
Yes, there'll be, it depends on how detailed the specification document is. So once you actually start your conversation with a packaging supplier, so I mean, if for example you're producing a product, I've never come across a product yet that was that unique that it couldn't be compared against something else. So if it's a thing that you actually end up like seeing a product that's on the market and it's packed in something like a laminate, there will be lots of companies that are able to produce that type of a laminate. So on a specification document, a very basic one, it will have things like barrier properties, strengths, heat seals, printability, all of that. When you start to have conversations actually with packaging people, they will start to realize that your product actually maybe is challenging from a pH point of view. It may be challenging in lots of different ways. And the idea then is they have to actually start providing you with the information to show you how that material is compatible with your product. But I work with a lot of companies, like, for example, again, new to the old ones. And essentially, if it's a thing that someone is thinking of actually producing the product, that's exactly what we're here to do, is to try and help companies look at specification documents, look at the type of products that in actual fact they're talking about, and give them some advice on what the next best approach actually is, and maybe even point them in the direction of the right packaging suppliers if we can.
Yeah. So call Joe. The next question, what's the best type of packaging for use with dried foods?
Well, with dried foods, when you're actually, when we're actually talking about dried foods, really, we're talking about products that actually have a moisture content of about 20% downwards. So typically if you're kind of talking about like snack food products, for example, certain types of snack food products exist within 15 to 20% moisture. And essentially, if you're talking about those, like a bag of crisps, for example, let's take an example. We're talking about a bag of crisps. A bag of crisps will actually have 2 layers of plastic with a coating of ink and a coating of metal, right? So essentially what we actually have is all 3 materials, the metal, which is aluminium, a coating of aluminium that's been applied to polypropylene, which would be on the outside of the pack. Polypropylene is a great moisture barrier. The metallization makes it an even better moisture barrier. And then the whole pack is actually heat sealed with something like an ionomer or low density polyethylene or EVA or something like that. And that will also be another good moisture barrier. So the logic actually is that if you're producing dried products, essentially you're trying, even if you're marrying different materials together, the one common denominator across all of them should be that they're trying to make sure that moisture doesn't get taken up by the product. If you actually start dropping moisture contents down below 10% in a product, and we have like instant coffee is a really good example of a product that contains less than 1% moisture, then essentially you're talking about using full-on metals or glass or combinations of both. So if most of you would think of your instant coffee at home, it's a glass jar. And of course, if you open the lid, what's the first thing you have to do is you've got to puncture the aluminium layer on top, an example of a hermetic pack. So the more dried the product is, the more hermetic your pack actually has to be. And when we say hermetic, that means 100% gas tight.
Yeah. And there's a question here, just wondering, I suppose you've done a lot of work with industry down the last 20 years. Is there any report, have you produced any reports, Joe? I don't think they mean kind of peer review papers, but actual reports for industry in terms of what you found in terms of your own research and testing in your department.
Well, the way we would work with industry is we'd work on a one-to-one with industry. So essentially the thing is, if we got contracted actually to do some work around, for example, expanding the shelf life of a particular product, we would work with a company actually on that basis. And it usually means when you're trying to add more time to a product, it's not just about coming along with some new packaging or a new packaging format and applying it to the product. You generally have to manipulate the product as well. So it's a manipulation of the product, changing or amending some of the packaging formats, and then trying to actually bring the whole lot back together again to extend the shelf life. So when in terms of the reports that we do the reports for the clients we work with. That's the outside of that, it is the scientific journals and peer reviews and things like that.
Yeah. Is there any particular packaging systems that people or companies should just stay the hell away from that you found?
Well, I suppose like one of the things, I mean, and I suppose a bit of advice to a lot of the companies that are actually out there, and if there's politicians watching, I'm sorry if I upset them with the next comment, but I mean, the bottom line actually on it is that if you kind of take leads from some of the really big companies around the world, they're probably shown the way that things are actually going to be around packaging materials in the future. So, I mean, I've never been down on plastics because I understand the importance of them and how good they actually are. And in certain cases, they're actually more environmentally friendly in a weird kind of a way than we'll say that the material that we were talking about earlier, when we were talking about glass, for example, because plastics become environmentally unfriendly when you can't actually recycle them or have a use for them. But if, for example, you're trying to pack a beverage in a glass bottle versus put a beverage into a plastic bottle, then all of a sudden environmental unfriendliness actually comes from the weight of the actual product and the packaging that you're trying to move around the globe or to your market. So all of a sudden burning fossil fuels in lorries where you're moving glass bottles versus plastic ones, straight away, if I look at it from that perspective, that becomes environmentally unfriendly. I think the thing that you have to actually watch is plastics. I mean, there's just a contingent of people that are actually out to try and get rid of plastics. And I have no difficulty with that in the long run, but you've got to be able to offer the industry alternatives to the plastics you want to remove. And if I was just to kind of give one bit of advice, I would stay away from plastics that are actually manufactured with halogens. Like the two examples that I gave of PVC and PVDC, the reason that they're not recycling friendly is because they actually contain elements from the halogen group on the periodic table. And any of those type of plastics that contain chemicals in that bracket, whether it's fluorine or chlorine or any of these, essentially they're not alone are they very difficult to recycle, but also in recycling them, they can actually give off a lot of very negative chemicals into the environment.
Yeah. Are they being phased out?
Yeah, I think what will happen is that again, if you look at the actual plastics list, and you can go in and you can see that all plastics that have been used around food for the last 30 or 40 years look like they're still available when you look at the listing. But actually, when you go to a company like, for example, Nestle or Pepsi or those, you're starting to see these companies move ahead of the legislators and start to actually take some of these materials out of the system. And the reason that they're actually moving ahead of I suppose, political drive is because if, for example, there was a ban on PVDC in the morning and everyone said you've got 2 years to get your house in order around the use of those materials, for really large companies that maybe have 60 global brand names and massive distribution systems, that would not be enough time for them actually to deal with that. So a lot of the bigger companies are just saying, right, if there's any question marks over this at all, we're moving ahead and making decisions from a corporate point of view to not use them. And I think that what will happen is that if that actually happens wholesale with really large companies, I think what will happen is later it'll be easier for the politicians to just go, we can ban these things because it's already been done for us by the industry.
Yeah. And just in terms of the whole intelligent interactive packaging technology, what evidence do we have that consumers will understand it and that they'll be able to act on the information that provides, rather than, for instance, what we have currently, which would be things like use by dates?
So say that again, James, in terms of the consumer?
Yeah, I mean, what evidence is there that the consumers will understand, the active or the intelligent packaging technology if they're applied to retail products?
Well, the thing about this actually is, it's sometimes actually scientists get on the wrong side of marketing Scientists should stay in the lab and not try to sell the technologies they make. Like one of the things actually about the second level packaging that I was talking about earlier on. One of the things actually about that is that when scientists created a lot of these, the aim, of course, was that you'd put one of them in every single pack. And essentially, it's in a lot of cases, it's actually not required. I suppose one of the things that you don't want to actually do around packaging is get yourself involved in having to also educate the consumer. Right? It's too expensive. And if you actually saw the billions that have actually been spent in the United States in trying to actually teach the American public how to read labels on the side of packs, it would actually show you there was absolutely 0 point in actually trying to. And in fact, we did trials in here where we put elements like that into packaging, and 7 out of 10 missed the technology completely in the actual packs. So what I would always argue with these technologies is that essentially, if I was a retailer and I wanted to instill confidence in my consumers and get more consumers to come to my retail outlet, it probably would serve me better to actually say that I have this type of a system in place, that we're tracking pH changes and temperature changes and all for the betterment of the consumer. They don't know what it actually is. They have probably no interest in it, but they'd be glad to know that there are systems in place that actually is looking after their health and well-being. And meanwhile, like the technology, so I was talking about like these various individual devices, okay? So if you had like one of those time temperature indicators, like I had outlined, what would be the point in putting one of them into every pack unless you wanted every consumer to understand how the technology worked? Or would it actually make more sense to put one of them on a pallet and follow the pallet from the manufacturer through distribution systems till it actually reached the retailer? And at every point that pallet was actually handed off from one to the other, you could take a photograph of the tag as you saw it at the time when the product was handed over. And if it fails somewhere along the line, you know where it's failed and you know who's responsible for it. So in my view, you don't need these technologies in every pack. You just need to use them correctly.
Yeah, and just a related question there. I mean, if you did have one of these technologies on a retail product and a consumer buys it, and then there's a change of color or something, and a time, temperature, abuse, or whatever it is from a domestic setting, whereas currently you might have a use by date. So if you bought it last week and you forgot about it and you missed the use by date, well that's your fault. Yeah. But what's to stop a consumer then taking the product back? Even to the retailer for a refund. Well,
and you make a really interesting point, James, because one of the things is that like a lot of those, any kind of devices inside in a pack, it wasn't the consumer who said they didn't want to see them. It was actually the retailer, because they were afraid, for example, if this was an example that was given to me one time, and it was, if you're 3 supermarkets in a small town, and you happen to get a consignment of chicken that comes in that has a tag in it that says this product has changed color and is now full of salmonella. Yeah. Well, the problem actually is everybody's going shopping in the other 2 places and not there. And it may very well have been something that's gone wrong with the technology or people misreading the technology. And this is where this whole education piece comes in, and whether you want to spend money on trying to educate the consumer or not. And most people involved in packaging and most people involved in retailing don't want to, right? It's bottom line on it is, if you can, the reason you might be implementing all of this is for the betterment of the consumer. And if you can get your message, if you can use a system, but get your message actually out to the consumer that we're doing all of this on your behalf, for your safety and so on, that would probably be the most logical way actually to go without training anyone.
We have a related question in terms of educating the consumer on recyclability and biodegradability as well.
Yeah.
The person here says that a lot will be lost is lost in translation about biodegradable packaging in terms of the need for it to be packaging industrially biodegradable.
Yeah.
So I suppose again it goes back to that, just the consumer's understanding and expectation.
Well, I suppose like one of the things I again, as part of my own job here, I end up like talking to an awful lot of people who manage recycling centers. And I mean, you saw the presentation that I gave, like where we were talking about conventional packaging materials at one hand, and I'm finishing off with what people are describing as the future of packaging materials in the years to come. If you went to a manager of a recycling center, he'd probably run you if you told them that next week you were going to actually bombard them with about 50 tons of biodegradable plastic-like materials, because he'd just basically turn around and say, wait a minute now, I have enough of a problem actually trying to sort out the actual plastics without you putting a contaminant in on top of my plastics, and I have no way of actually knowing which is the plastic and which one is compostable and which one isn't, because they all look like plastic. So that would be one. And the other one, I would go back even further, whatever about actually the education piece around consumers. Another thing that recycling managers have basically told me is that, whatever about the messages you want to actually give to the consumer, how can you actually get 10 houses in an estate to actually simply take all their materials and put them into the right bins, to make sure that like they wash out the containers that actually go into because you have the reports that come back where 80% of households in certain parts, in certain estates around, and it's known here even in Cork, where essentially 80% are making an effort to separate everything, and the 20 that don't will have their waste that's mixed and filthy that now contaminate all the effort that was made by the 80. So when you go talking like to people actually like recycling managers, they can hit you with some really hard and tough facts and scenarios that sort of have you coming back and going, what am I doing? What am I doing in the lab?
That raises a good question, Joe, in terms of the compostability of materials, because if is there a certain amount of this phrase we hear, greenwashing at the moment, in terms of I mean, material could be described as compostable, but is it actually going to be composted, or do they have to take the entire chain into account if they describe something as compostable?
Well, you see, I mean, again, we've been asked actually to end up like getting involved in testing to verify whether certain materials were compostable or not. In a lot of cases, what we were presented with, we found that materials actually weren't. And those that actually have made a huge effort to kind of try to produce compostable packaging, even by their own admission, I mean, there's a good company here. I'm not plugging any one individual company, but we did a lot of work with them over the years, and they're called Down to Earth Packaging. And just as an interesting story for all that's kind of listening to this, but essentially, John Lynch, who works in that particular company, he's been very good to our students over the years on projects, and we've done a bit of testing for him on. And they were the first company with a compostable coffee cup that actually was licensed for use. And he actually appeared on EcoEye. So most of us actually know that particular program. And Duncan Stewart was basically asking him, he says, isn't that fantastic that you have this compostable coffee cup? And he said, wouldn't it be great now that all the coffee houses actually in Cork actually take on this compostable coffee cup? And John said, it sounds like it'd be a great idea, but in reality, it would probably be a disaster. And Duncan Stewart was really taken aback, because this is the fellow who actually was pushing the use of the compostable packaging. And he says, what do you mean? And he said, well, the problem is, he said, if everybody actually goes inside and they take a carry-out coffee with them, they're walking around and they're not going to actually bring that compostable cup home to compost it actually at home or put it into an appropriate bin. They're probably going to actually throw it into a municipal waste bin around on a particular street. So a lot of the efforts that we've actually gone to try and create the actual packs have been lost, because essentially we're losing the compostable packaging. because there's no specific places to bring them in a
Yeah.
city to deal with them. So I don't be dashing everybody's kind of questions, but like it's kind of just trying to, I suppose, in a way, show the complexity of all of this in trying to get systems right.
Yeah, would we need to have, oh yeah, do we need to have a specialized degree to understand a specification document?
Not so much, right? But again, the thing is, what I certainly, if anybody is thinking about buying packaging materials and they need terms and that explained, if, for example, the packaging people that you're hoping to buy the material off doesn't explain it, there's plenty who can. Yes, a lot of what will be on a specification document, as you'd imagine, would be technical. And again, it's technical because if, for example, you bought packaging from a company and you were going to use it for a product, one of the things that you might do, and it's actually something that the Food Safety Authority have actually become interested in more recent years, is trying to actually figure out, did anybody actually take the packaging they were given and send it to an independent lab where it was actually tested to validate whether or not the figures that were actually given on your specification sheet are real, whether they stack up or not. And so essentially, if, for example, I'm sending, this is something I say, for example, to companies, if you've got a specification document for a material, you must actually understand like why you're actually buying that packaging material, that you've had a discussion with the supplier as to the type of product that's going into it and where that product is actually going to be sold in the world. Because again, the thing is, you can actually, the devil is in the detail. A lot of the information that's on the actual sheet, you'd have a kind of a fair idea what it's actually about. But for example, there are tests that can be done under different pressures, that can be done under different relative humidities, that can be done under different temperatures. And essentially, you need to actually know, for example, if I'm going to actually pack a product and that packed product is going to make its way to Malaysia, then I actually need to know that in actual fact, that packaging material was tested by the packaging company that sold me the packaging materials under the conditions that it's going to face when it goes to Malaysia. Okay. And that actually does sort of, that's where the detail, the devil in that detail may go over someone's head and they actually don't see the significance of it.
Somebody wants to know if there's a list of Irish or European packaging suppliers available somewhere.
We had, well, the grouping that actually had a directory was the Institute of Packaging.
Okay.
From time to time, they basically pop up. They're called IOM3 now, and they're based in London. So essentially, every year they do a directory on packaging. And you'll have to pay for it, obviously, but it's there. And if you're a member of IOM3 or the Institute of Packaging, as it used to be called, you'd be able to probably get it for a fraction of the price. But that directory is changed every year. You have a new directory for every year, and it's supposed to actually contain all of the members of IOM3 in the UK and Ireland.
That's great. And Joe, for plastic packaging, Joe, do they use recycled plastic packaging as food packaging at the moment, or does it have to be?
No, this is a
newly made plastic.
That's a really good question. And one of the things that we're doing a lot of work actually at the moment on PET. And looking at its recycling and recyclability and reuse in various different containers. And one of the things is, depending on, we know this, that depending on the thickness of the PET that you use, and depending on the amount of different additives that you actually add into the PET when you're actually forming it, you can have a lifetime of recycling in PET of 3 times all the way up to 12. But one of the things that actually happens, just like it does with paper if you recycle it, is that the the monomers that make up the actual polymers basically break down. So their structure becomes weaker and weaker each time you recycle it. So one of the things, and I had this conversation with 3 companies last week, and they basically said, we're not taking in any recycled plastics actually here. And I said, have you got that actually in writing with the supplier of the actual companies? Because you do know that every month that you buy in an order of plastic, that plastic actually has been reformulated. Now, unless you actually have an agreement in place with the people who are supplying you with the packaging, there's every chance that recycled material may actually be going into your product. And going back actually to Carol's presentation, like essentially, if you're talking about monomers that are unstable because they're actually breaking down in structure, they're the very materials that could migrate actually out of packaging and into your product. So we don't know the consequences of that. Everybody right now is actually talking about the amount of recycling that they can do for plastics to build them back into products that can go around food. Now, for nearly 20 years, the understanding was that if you recycled plastic, it would never make its way back into direct contact with food products. And now everyone's talking about putting it back in direct with food products and beverage products. So my argument would be nobody really knows what the impacts would be of you actually using packaging with a high recycled plastic content in it. And my advice is you would not want to be the guinea pig or the canary in the mine, actually to end up like finding out the hard way that was probably the wrong thing actually to do. So going right back to Carol's presentation, if I was getting materials actually in and I knew there was a 30% recycled plastic content and it was going to be used again like PET for a plastic bottle, I certainly wouldn't be putting any product into it till I actually tested it to see what amount of migration I would actually get from that particular plastic.
Yeah.
And I still don't really understand why people actually have moved away from and so soon to basically saying we can use these materials in direct contact with food products and beverage products again, because it was a no-no for years.
Yeah. Joe, I'm just conscious of the time, but there's just 2 more questions really. Do products which use active packaging have to be labeled as such?
In terms of not as far as I know. I mean, it does fall in under contact materials. The big issue actually around the active packaging is more from a recycling point of view. So, but I suppose like where we're at now in terms of secondary packaging or second level packaging is that we've gone through various different generations of those technologies. So the ones I was kind of showing people were the old ones, but there's a lot of these materials now that are integrated into the actual packaging themselves and you wouldn't see them. So the idea is that when you get to that stage, they shouldn't be interfering actually with the recycling of any of the materials after.
Another question here, any work done on recycled HDPE?
On recycled high density polyethylene. In terms of it being used back around food products, I'm not aware of very much work in that space, but recycled HDPE has been used for donkey's years, where again it would actually the high density polyethylene, because it's so robust, would have actually been used, for example, might have gone, for example, where you were using it for a milk bottle, for example, and might have then made its way back actually to being rechipped, colored, and formed into bottles that the next time around might contain engine oil or pesticides or herbicides or something like that.
Yeah. And just on the note of contaminants, then somebody asked, what part of packaging production process do the PFAs, the polyfluoroalkyl substances, come from? Is that paper manufacture only, or paper packaging, or is it?
Well,
is
we're
it
talking about, sorry, about the
PFAs, polyfluoroalkyl substances. I presume PFAS and PFOA, things like that.
Well, you see, a lot of the substances, right, they may find their way actually into certain plastics. A lot of those would actually be in plastics, but they're also actually used as processing aids. This is actually where some of this gets very interesting, is that some of these actually materials are not supposed to be present in the actual plastic, but may be used actually in the manufacture of the plastic. And I suppose one person recently said to me, what's going to happen actually if they manage to end up like banning them from use because you don't want them in the plastic? Are they then going to go one step further back and go, well, they were poisonous to have them in the plastic. Why are we using them in the process of manufacturing this plastic? And all of a sudden, you might actually find plastics that look like they have a clean bill of health actually starting to be scrutinized because they're using some of these same substances in their manufacture.
And there's just a final point here. Somebody made that with regard to greenwashing. The European Union has said that the term single use will not be allowed on items, or sorry, for single use items rather, they won't be allowed to use the phrases compostable or biodegradable in the new legislation, as they fear it would cause extra litter.
Yeah. Well, and that was the point that I actually made about PLA, that the PLA, which actually in terms of just being used to form plastic-like bags, it was also used in single-use plastic bottles. But again, it falls actually on the same sword as the single-use plastics. So even though it is compostable, and industrial compostable, no one wants it because it's single use. Yeah. So we fall into the same camp even with the biopolymers. Yeah.
Are you aware of any monolayer materials that work and are recyclable? Monolayer materials?
Well, monolayer, well, I suppose that's the whole reason why some of the laminates have disappeared for use around, particularly in the meat industry. And why, for example, we are now using PET lids and PET trays is because they want to keep it as a single material. Now, I have my doubts because in any of the tests we ever did inside in our own lab, I could never get PET to stick to PET stably. So it means that something else is actually being added to the PET in order to get a lidding material that's PET to stick to a PET tray, right? But it's supposed to be a single recyclable material. And that is really the biggest change. And this kind of happened about 2 years before COVID. And I was kind of keeping up to speed with it. And then of course we had COVID. And after, I was really curious, not about the change from the laminates to the single materials. I was curious about what impact that actually had on the shelf life of food products, and whether you actually maintained the shelf life as a retailer would demand from those products, or did you actually lose shelf life as a result of making that change? And I don't think an awful lot of work is actually done on shelf life evaluation when packaging modifications are actually made.
So we have no more questions. I'm conscious of the time. Look, I'll wind it up there, folks. Thanks to Joe for a fantastic presentation and a very robust discussion session afterwards. Thanks also to Carl from the Food Safety Authority of Ireland. Folks, you'll be emailed a link to a short evaluation form. So I'd ask you to fill this in as soon as possible. I'd like to draw your attention in particular to two questions. One concerning specific aspects of food packaging, maybe, that are food contact materials that you think you benefit from, if you like, a deeper dive into those particular issues. And a second concerning other food safety issues that you think would be suitable material.